Great. Well, we are so glad to have everyone joining us today. This is our first MIT Sloan Alumni Online event of the academic year. So if you are in the Boston or Cambridge area, you know that there's a buzz in the air. Students are back, classes are getting ready to start. So it's just a really exciting and fun and really busy time of year. So thank you for taking time to be with us today. We're especially glad to have Manish Raghavan, the Drew Houston 2005 Career Development Professor and Assistant Professor of Information Technology here with us today. So Professor Raghavan teaches a course titled AI for Business. So we're excited to dive into the conversation today and learn more. AI, of course, is a hot topic these days, so we're looking forward to separating some of the signal from the noise and just learning from Manish in his online classroom today. So Jackie Selby will be moderating our session today with some prepared questions, but we also invite our audience to submit questions via the Q&A panel in your Zoom interface. So with that, Jackie, Manish, thank you for your time today. We'll go ahead and turn it over to you.
Okay, thank you very much, Greg, and a big thank you to the Office of External Relations for your ongoing partnership in this series. And we also, of course, want to extend a thank you to everyone who is joining us today. Thank you for taking the time out of your day to do so. As Greg noted, after a brief summer recess, we are excited to return in the fall to tackle this very timely topic that has seen really an overwhelming level of interest from not only the MIT community, but of course beyond, which is of course the business implications of the proliferation of AI. So it really is a privilege for me to invite Manish to join us today and to say welcome, to dive into this area of interest. So Manish, thank you very much for taking the time out of your day, particularly at the start of classes tomorrow, just to share your insights and expertise with the community.
Of course, yeah, thanks for having me.
Thank you. So before we begin, would love to invite you to share a little bit more just about your personal background and experiences that, of course, had an influence on not only your career path and also your areas of academic interest, but of course, our conversation today.
Sure. Yeah. So my background is in computer science. It's what I've done all of my degrees in. I did my PhD in computer science and thought I was going to go to a computer science department. Actually, coming to MIT, I sit 50-50 joint between computer science and the business school. And most of the research that I do is on how AI impacts society in various ways. A lot of that has to do with regulation of AI, what sort of policies make sense to put in place around it. And generally broad societal changes that are coming as a result of AI. So it's a nice place to sit in between the business school and the computer science department because I get to see a little bit of both worlds and see how they fit together.
Absolutely. Absolutely. Well, thank you. So, as you mentioned, you're interested in exploring the social impact of computational techniques and online platforms, algorithms, and behavioral economics. So could you share a little bit more about how this topic became of interest to you and the impacts that you see and how it's impacting your research today?
Yeah, I think when I got into computer science research, I thought I wanted it to be more theoretical. I think I wanted to be a CS theoretician. And the more time I spent working on it, the more I realized that the surfaces where people touch computer science AI algorithms were just increasing quite quickly. And so it felt like the most important objects to study were actually those interactions where people start to come into contact with computer science. I think computer science as a field really likes to abstract away the real world and try to focus on solving computational problems. But obviously, in order to make those meaningful, you have to then apply those solutions in the real world. And I think that's where a lot of the challenges come in. So over the course of many years, I think I started to appreciate more and more how the social sciences matter, how it just understanding how real people work with technology matters. And so that's led to a lot of my personal and research interests in the subjects today.
Mm-hmm. Absolutely. Well, it's a perfect segue to my next question. As Greg mentioned when we first launched, that you have a course that launched in the fall of 2020 called the AI of Business, or AI for Business, excuse me. So could you share a little bit more about just your vision for the course and the purpose that it serves for the students who elect to take it?
Yeah, so this was actually inspired by a mentor of mine who teaches a kind of similar course, or at least used to teach a kind of similar course at Chicago Booth. I think a lot of people come in to an MBA, especially at MIT, wanting to learn more about AI and machine learning. And you might think that the way to do that is to go take a technical AI and machine learning class. And I'm not sure, I think that can be useful for a certain type of person. And if that's something you're interested in, you should obviously do it. But it's not clear that that is the thing that best prepares you to actually go work with AI in the real world. What I noticed in my classroom is most of the people there did not actually want to spend their days training machine learning models. That wasn't why they had done an MBA. That's why wasn't why they were at MIT. What they wanted to do was make good decisions about AI, about deploying it, about products and services that involve it. And that requires a very different type of knowledge and expertise. And, one way of, I think the wrong way of viewing the class is that it is a less technical AI and machine learning class. I do think that's the wrong version of it. I think of it as most machine learning classes in a computer science department teach you how to solve a particular problem. I think the course that I wanted to teach was, if you could solve that problem, what would you do with it? What would you do in the real world with this magical tool that is machine learning, AI, whatever you want to call it? And so that was how the class was really structured. Given that you can hire a machine learning engineer, they know how to solve this technical problem, how do you create conditions for success? How do you evaluate whether someone is doing a good job? How do you build products on top of the technology that we have? So that was the vision for the course. Some of I guess the students from last year can tell me how well it went, but I had a lot of fun putting it together. It forced me to see things a different way as well. And I did really come around to the idea that there's just a different set of knowledge that you need that a computer science department doesn't actually train you for. A different set of knowledge that helps you figure out, how are these tools going to be useful in the real world? How do I apply it? How do I communicate with engineers? How do I communicate with managers who are less technical? And so all of these elements I tried to wrap up into this course. And again, we will iterate on it in future years, but hopefully it was a good start.
Absolutely. So you've alluded to this, of course, AI has implications for business, but there are also kind of broader social and ethical impacts as well. So could you share a little bit more about your perspective on that? And are there areas of concern that you have?
Yeah. So I think when people hear AI, I think maybe one thing that's useful to distinguish is when people hear AI, I think, especially now, you think of it as generative models are sort of the pinnacle of AI. I think that's how just colloquially it's been come to be understood. Maybe that's true. I think maybe that's where things are heading. But the most commonly deployed technologies now are just much simpler predictive technologies. And so that is the focus of a lot of my research. It's also the focus of an undergrad class that I teach, actually, that I'll be teaching this fall for CS undergrads, and just sort of social impacts of AI and machine learning. And there's the domains where people use machine learning is just vast. I mean, I really got into a lot of this work looking at machine learning in the criminal justice system, where people were trying to use machine learning to predict recidivism. So sort of Minority Report style predictions about who is going to commit crimes in the future. And this is used in courtrooms all across the country. They have severe problems that people are pretty well documented, but they also are trying to compete with human judges who are quite fallible and also have their own sets of problems. So they're complex social problems that then get wrapped up into this question of, how do you build a good machine learning system? How do you evaluate whether it's doing a good job? How could you make it better? So that was my entry point into it. A lot of the work that I do now looks at machine learning in employment settings. So how do you use machine learning to predict who's going to be a good employee, or what sort of salary ranges you should expect? There's all sorts of applications of predictive technology in employment. You see a similar range of applications in consumer finance. In my class, we talk a little bit about machine learning in healthcare as well. So it's just being used in all of these different, very high stakes domains. So that's one set of, I think, things where we can pretty clearly see if you make mistakes, if you have biases, any sort of issues in these high stakes settings are quite problematic. And then on top of that, I think a slightly more recent interest of mine, and again, something I talk about in my course, is the use of AI and machine learning when it comes to the dissemination of information. I mean, a lot of us get news and other sorts of content and information from online sources. Most of those are algorithmically curated, that there's some predictions being made about what you are going to interact with, what you want to see, essentially. And so even though each of those decisions individually we think of as somewhat low stakes, like, does it really matter if I see this Twitter post or that one? But in aggregate, they can actually have quite large impacts, right? And so it's a little hard to reconcile that, where it doesn't feel like the particular thing I watch really matters, but at the same time, we think of, disinformation campaigns as being quite impactful, or attempts to sway elections through political advertising, or through general manipulation of social media algorithms. So that's another, I think, increasingly important class of AI applications to scrutinize, is what are the social impacts of having algorithmically curated news? And just to tie this back into the generative AI piece, I actually do think that one of the impacts that we're already starting to see is people trying to use generative models to create this content that they're then, shopping around, trying to see what they can get in front of people's eyes. And it just creates this feedback loop, really, with people trying to game the system, people trying to create content, consumers who are unaware that all this is going on. And it feels increasingly important from my perspective to really study what is the algorithmic piece here doing to us, and maybe is a more optimistic take, how could you construct them to be better aligned with what people actually want?
And if you don't mind, so do you, when you think about kind of providing that level of advice to your students, how do you think about having stronger alignment between, kind of what you want to achieve in positive outcomes and the negative outcomes you outlined?
Yeah, so part of what we talk about is, how do you even systematically and rigorously study the negative outcomes? Like, I'll give you an example. In probably 2018, many of you may have seen articles that had come out saying YouTube was radicalizing young men. I think that was a sort of common perception and common theme at the time. And there's some evidence that this was happening. You could anecdotally go just to YouTube and start clicking on the first recommended video, and you would sort of end up down this rabbit hole, typically of problematic content. But then there's a question of, how do you measure whether this is happening at scale? How do you actually know who this is happening to? How do you disentangle YouTube's role in this from people's choices to consume whatever they want to consume, and having the freedom to do that? So the measurement piece of it is already just challenging. And then there's a piece of it which I think of as a more behavioral piece, which is a lot of especially the earlier stage social media recommender systems were primarily driven by people's choices, right? They're just sort of predicting, what are you going to engage with? What are you going to spend time watching, and trying to maximize the time that you spent on the platform. And I think this pretty quickly revealed a disconnect between what people do and what they say they want to do, right? Nobody's social media browsing is really a reflection of their best self, or maybe it is for you, but for me, it's not. And for many of us, it's not. Right? And so there's a fear that purely optimizing for engagement starts to exploit the wedge between what we do and what we actually want to do. And so recognizing that we as humans are imperfect and we have behavioral flaws. I mean, one solution to that, I think, which some people have embraced, is, I'm just giving people what they want. It doesn't matter if you say you want this, science videos and Khan Academy and whatever. If all you watch is celebrity gossip, then that's what I'm going to give you. But I think there's also a recognition that maybe one goal of social media, or one goal for information curation algorithms in general, should be to help us express our better selves, as opposed to playing to those worst demons. Having spoken to some of the folks that work on these models and build them, I think we're sort of in a stage where people know that this is a problem, but don't actually know exactly how to address it. Right? There are these problems that social media seems to be driving, or at least contributing to in some way, but there aren't really obvious fixes. And so that's, I think, part of the goal of the research over the next 5-10 years, is to really figure out a little bit better, how do we think about the human in this process? How do you sort of allow that human to express the best version of themselves, as opposed to viewing it as you're simply trying to optimize revenue or engagement or whatever it is, and whatever human consequences there are, those are the consequences. So I'm hoping that there's going to be a shift coming, but I do think that shift also requires more rigorous work on the scientific side to even understand how should we push in a better direction? How do we understand what that better direction looks like?
Hmm. No, I really like that, helping us to express our best selves, and that's wonderful. And actually, that leads really nicely into one of the things that you've talked about, which is to really focus on understanding the context with which AI systems are deployed, and that context really contributes to whether or not they succeed or fail. So, could you talk a little bit more about how you architect the right kind of system and framework to help foster success?
Yeah, so I'm going to say the cop-out answers, it depends heavily on the context, but I think that's true. I think some general pieces of advice or general lessons that I've learned, it's very easy to look at a machine making predictions and assume that those are right in some way, that they're computational, they're hard numbers, you can look at them and you can make decisions based on them. I think a healthy amount of skepticism is useful. And what that translates into is really trying to prevent these systems from being deployed in ways where they're too independent. And you really want more oversight, more fault tolerance, really. Like, I'll give you an example. One of the things that I think has been really surprising over the last 5-10 years is that we got AI that can generate art for us before we got driverless cars, right? I think that would have surprised people 10 years ago. That's if you told me that 10 years ago, that would have really surprised me. But I think in hindsight, when you look at it, the reason is actually quite clear, which is that when a system makes a mistake generating art, nobody really cares. When a driverless car makes a mistake, everybody cares, right? The consequences are huge. And so even if the driverless car system is much more accurate, much more reliable than your art generation system, it doesn't matter. You still can't deploy it, right? Because the safety requirements for an application like that are much heavier, right? And so figuring out ways in which we can deploy AI in ways that it's not really about improving the system itself, it's about improving what you do around the system to make it more robust to the mistakes that the system is going to inevitably make. I think that's where a lot of the gains to be made are. And a lot of the AI and machine learning communities focus on just sort of optimizing for the performance of the system itself doesn't really reckon with the broader context in which it's deployed and sort of producing an environment where it's more likely to succeed. But fault tolerance is definitely a big piece of it. I also think that a better understanding of human consumers and human users of that system is super important. For instance, you see when I've looked at machine learning models deployed in the criminal justice system, what you end up seeing is that judges really start to either lean too heavily on these systems or just ignore them altogether. Right? Where this thing comes back to you and says, you know, I think there's a 30% chance of recidivism for this particular defendant. It's very easy for a judge to say 30%, that's my justification for denying this person bail. I don't, you know, that's sort of by default, my answer should be, I listen to the system and not really question. And it's very easy to outsource your thinking and to a black box that you think is doing all the work for you. So accounting for human factors in the system, some of the people I've worked with in the past refer to this as sort of hybrid intelligence, right? How do you actually get the best of human decision makers and sort of data-driven insights that you get from machine learning models? I don't know if I have better advice than it is incredibly context dependent. But I do think that just accounting for the fact that people are not machines, people think in different ways. Sometimes that can be beneficial, but they also make mistakes in different ways. And sort of figuring out how to leverage the strengths and weaknesses of both types of decision making you have, I think is an important step in sort of deploying robust AI systems.
And you and I also talked a little bit about just the measurement challenge that comes along with that, meaning, you know, that either it's their underinvestment in measurement or just a mismatch of incentives. Would you mind talking to that a little bit?
Yeah, I think the easiest way to try to build an AI system is to take whatever data you have lying around and then hope that it works. And you sort of scoop up whatever data you have on the floor, you run it through some predictive model, or maybe now a generative model, and you get outputs and you just say, great, I'm going to use these, and that makes sense. I think there are at least two ways in which you can do significantly better than that. one is to think hard about what data you want to actually invest in. What is it worth collecting? What do you not know right now, or what do you not collect right now that actually would make a huge difference if you did collect? I think this is where it's actually quite hard to replace human intuition and expertise, primarily because the whole challenge when you don't have data is you don't know what you don't know. And there's no machine in the world that's going to be able to compensate for that. You know, if you simply do not give it access to certain types of information, it will not be able to use that information. But humans do have some intuition about what are you lacking, what could be useful from a predictive standpoint. The other measurement point that I think people systematically miss is that investing in infrastructure to measure outcomes and measure the performance of a system is actually non-trivial. Like the amount of resources at, for instance, a big social media company that go into actually rigorously running like randomized tests on the models that they're building and evaluating outcomes is huge. Right? There's hundreds to thousands of experiments running at any given time on, say, Instagram. Right? Most companies don't do this. Most of the time, you just sort of take whatever measures you were already collecting and see if they go up, and then maybe that's a good thing. If they don't go up, then maybe that's a bad thing. But it is really hard to get rigorous evaluations of what is actually working and what would it mean if your system was failing. And part of that is, as we said, it is often just really hard to measure the thing that you care about, right? Let's say you're actually trying to build a social media company that makes people happy. It's very difficult to measure whether people are happy or not, right? So you end up measuring other proxies instead, or things that you think are proxies, right? Things like engagement, watch time, you know, how often they return to the platform, that kind of thing. And those are proxies for happiness, but over optimizing towards those proxies often leads to a disconnect between them and the actual target that you were hoping to look for. This is so anyway, there's a long literature on sort of the folly of rewarding A while hoping for B. You know, if you have a proxy and you optimize towards that proxy, it sort of ends up failing to be a good measure in the first place. This is Goodhart's law for those of you who have heard of it. So there's measurement, I think, in general is a piece that people underinvest in, and as a result get worse outcomes.
Mm-hmm. Yeah, thank you. So that kind of leads me to, I think, a next question is, you know, certainly there are many business professionals in the audience today, and we'd assume that many of them are also interested in thinking about, you know, how they could incorporate AI systems into their company or start to evaluate the application or optimization of those systems. So is there, do you have any advice that you would offer, or kind of a perspective or point of view that could help those individuals think through the problem?
Yeah, so one of the things that we cover in my classes is like a bunch of heuristics for when is or is not AI a good solution to the problem that you have. I'll give you a few. It's been long enough since I taught it that I don't have to list off the top of my head. I'll give you a few general points that I think are important. One is that people often mistake predictive problems for causal problems, and that actually leads to a lot of problems. And what I mean by that is, a lot of the times when we make predictions, it's because we want to make decisions on the basis of those predictions or act on those predictions. And part of the problem, maybe the best analogy is, if you work for like a pharmaceutical company, for instance, and you're trying to understand the efficacy of a drug, right? You don't just look at the people who are taking the drug and see which ones get better outcomes and which ones get worse outcomes, right? You actually run randomized trials. And the reason that you do that is you're not just interested in predicting who is going to be healthy. You're interested in the causal effect that your actions are going to have on people's health, right? The infrastructure that you need and the types of the way that you approach causal problems is different from the way that you approach predictive problems. Causal problems require randomization. They require just sort of generally different technology from predictive problems. So step number one is figure out whether you're trying to solve a causal problem or a predictive problem. If you're trying to solve a causal problem, your machine learning is not really your solution, right? There's some techniques you can use or some ideas you can use to try to turn causal problems into predictive ones, but this is not the right forum for that. But the common pitfall that you see is that failure. You see it in marketing, for instance. A lot of the time in marketing, you're not really interested in predicting who is going to buy stuff. You're interested in predicting the impact that the message that you send out is going to have on people's purchasing behavior, right? That is a causal problem. It's not a predictive problem. And so machine learning and marketing often runs into that sort of pitfall where you end up predicting, if I try to target this text message campaign, who's likely to click on the link? That's very different from whose behavior am I changing by sending out this text message. So that's sort of a high level distinction you can draw. In general, when you actually do have a problem that you can solve through machine learning or through AI, high quality data is often the most sort of significant driver of success. Right? If you have data that are that truly measure the thing that you're looking at, there's not a lot of measurement error in it, where the information that you're collecting actually is meaningfully related to the outputs that you are trying to predict. These are all sort of signals for when you have a reasonable setup for a machine learning problem. Other things it's hard to sort of give an exhaustive list of what makes AI a useful strategy or not. The other thing I will say is just harping back on the measurement point. If you're in a system or deploying a system where you have enough control to actually measure the outcomes, measure the performance, and iterate and provide feedback, those applications tend to be more successful as opposed to you deploy a system, you don't really know what impact it's having. This may not sound like news, but you'd be surprised at how many people just sort of buy off-the-shelf machine learning products, try to deploy them, and don't really have any feedback mechanism for improving them. So those are just sort of a few high-level thoughts on what you would do. Again, highly dependent on the context that you're working in. What I will say is one thing that I've noticed is changing is folks who are trained as machine learning engineers. Traditionally, that training doesn't actually include a lot of rigorous instruction about how to deal with the real world. A lot of your sort of education as a machine learning engineer used to be, you would learn how to build models. You would learn, given data, how do I use that data productively? But you wouldn't really learn to ask questions about, is this the right data? Are there ways I could be collecting better data? Are there ways that my measures are sort of not really doing the things that I want them to do? I do think that that's changing. I think that students, especially the students I see, coming out of MIT here, are asking those questions more and more as we go. And the sort of enrollment numbers, maybe if that's a proxy, in classes that try to teach about this, have shot up in the last 2-3 years. So I do think there are some signals that the engineers themselves are also learning to ask better questions on these fronts. But a lot of the times, this is the job of a manager, not necessarily, or a product manager especially, not necessarily an engineer, to ask the difficult questions of, should I even deploy this system? Are there ways that I can systematically invest in the infrastructure around the system to make it better, even if the model is what it is right now? But yeah, those are just a few general thoughts on what makes it a useful or an AI deployment likely to succeed.
Absolutely. Well, thank you very much. And kind of building upon that, and certainly a topic that has been in discussion in the news, is concerns around the impact of AI and the possibility.
Sorry, the possibility of.
Sorry, job replacement. So could you share just your thoughts on this and an issue?
Yeah, I'm going to hedge a little bit because I actually don't think I have a very good intuition for the job replacement question. What I will say is, in the near-term future, I think job replacement is perhaps not the most likely outcome. I think it's pieces of jobs are getting incrementally automated. And this is sort of something that technology has done over many years. But for instance, if you look at the job description of a lawyer, we wouldn't actually think that it's likely that we're going to have AI systems in a courtroom arguing cases anytime soon. I don't think that's a good idea, first of all, but I think that's unlikely to happen. What I do think is likely to happen is that the distribution of how lawyers spend their time is going to change over the next 5-10 years. Right? For instance, discovery is going to get easier. Right? Sifting through, it already has, I guess, but sifting through thousands and thousands of pages of documents, you just don't need to hire someone to spend thousands of hours doing that. you are going to outsource some of that job to an automated system, right? Or to some extent, you already do. So it's in ways like that, the ways that people are going to spend their time are going to change. Now, that can result in two things, right? Either you need fewer of those people, or there's going to be increased demand because the price is going to go down, or both, right? So in the long term, yes, I think it also results not necessarily job replacement, but reallocation of where people spend their time and resources. It does say something about what do you think is a good career to go into, maybe as someone who's just going into college or just coming out. So it's, I don't think of it as replacement as the primary concern. What I do think is it's actually quite interesting to see how people's projections have changed. If you look at projections from 5 years ago about which jobs were more or less automatable, I think have changed dramatically with sort of recent breakthroughs in generative modeling. Simply because generating text in situations that are somewhat low stakes, where someone can, proofread the work, but doesn't, like copywriting, someone can proofread that, but just generating the text used to take a long time. Now it takes less time, right? It may be lower quality, but people seem to be willing to eat that cost for the savings that it brings. So it's going to change the distribution of time. I think one significant challenge that I actually don't really see a good solution to right now is, at least the systems that we have seem to be better at automating the tasks that more junior people do in a sort of in hierarchy within a job role. Like I saw there was a comment about Hollywood writers. It is generative models are more likely to impact the more junior writers than the more senior writers, the ones who write the first draft and who sort of take direction from the senior writers. But what that does is it creates a pipeline problem where if you need fewer junior writers, who are then going to grow up to become the senior writers over time, right? So it's actually, there are some longer term knock-on effects that this might create. I do think the Hollywood strike right now is actually sort of an interesting window into fears of really automation and at least some amount of replacement. There's a question about, from a policy perspective, what people should do to protect jobs or at least ease the transition. I don't really know if I have super strong views about that, but I can clearly see why unions are interested in slowing the adoption of some of these technologies, especially as people figure out, what is the right model to integrate them with people who already rely on this for their work.
Absolutely. Well, certainly there are no easy answers to any of this. So, but thank you for sharing your perspective. So let's just shift gears a little bit and talk about the relationship between content and AI. Could you share just your perspective on how AI may have an impact on just the moderation and also curation of content?
Yeah. I used to think of it as there were sort of two key functions that AI was performing when it came to our access to information. One was moderating what people are allowed to say, and the second was curating what people see. I think there's a third function that is being added, which I still don't think has been super impactful, but it possibly will, which is content generation. That more and more we're going to interact with content that a person hasn't actually produced themselves. There's actually interesting stories that came out recently that were in somewhat tragic, that there's a bunch of books, you may have run into this, there's a bunch of books that people are selling on Amazon that are AI generated on recognizing different species of mushrooms. Turns out that AI makes mistakes a lot, though. And if you make mistakes with which mushrooms you eat, it's actually quite dangerous. And so there have been reports of people getting sick from, you buy this book on Amazon because you're interested in going foraging, and then you eat the wrong mushrooms, and it can be quite sad and scary. So anyways, the fact that AI is now, at least to some degree, generating content, I think opens up a whole new host of issues. But we've been using AI and machine learning to curate and moderate content for a long time. On the moderation side, I think there's quite strong interactions with sort of policy about what people are and are not allowed to say and what they should and should not be allowed to say. You see a lot of this playing out with some of the fights that in the social media sphere over basically what the window of acceptability looks like and what should be sort of beyond the pale, what is considered harassment, what is just people don't want on a platform. I think more and more of that functionality, though, is actually getting getting reallocated to content curation, which is more of the philosophy that let people say what they want to say, but nobody has an obligation to an audience. You don't have to show that content to anybody. And maybe that is a fair approach, but there isn't a lot of transparency actually into what curation systems look like. What does it mean for them to be neutral in some way? Is it even possible for them to be neutral? There's a couple of Supreme Court cases actually that just got heard on both Google and Twitter's moderation systems, and the extent they can be held responsible for the downstream consequences they produce. I think there's a lot of hard questions really on, what should a company be allowed to promote? What should they not be allowed to promote? What does it mean for them to be sort of exercising their own editorial judgment versus just deferring to the judgment of users? And a lot of thorny legal questions wrapped up in it. But it also speaks to some of the technical challenges that, you may want control over the system. You may want to be able to steer the recommendations or the curation towards things that you want. It's actually hard to expose those controls to people. And it turns out that even when you try to, most people don't use it. No one really wants to spend a lot of time fiddling around with their social media algorithms. And so there aren't a lot of easy solutions there. But I do think that the impacts that they're having at scale are really quite worrisome. There's a lot of studies that have come out recently on the mental health effects that they're having and so on. Different countries are putting in different restrictions on what you're even allowed to do, especially when it comes to children interacting with these systems. So again, no easy solutions, but I think a very important area of concern and one that I'm hoping to spend a good chunk of the next several years working on.
Absolutely. Well, certainly another area of concern, and you mentioned this in regards to the writer's strike, is just general policy and governance. So could you share your thoughts on, what we should be regulating or should at least be thinking about regulating when it comes to AI?
Yeah, how should we regulate AI? It's an important question. It's also, I believe the Senate is planning on spending a good amount of time on this in this upcoming session, so it's quite topical. There's different models for how to do this. I think the EU has gone probably further than anyone else has on really trying to regulate AI. They've done a number of things that I don't think are particularly useful. But I don't want to be too critical because it's not clear how this stuff is going to pan out. But that style of approach, I think, where they're trying to basically say, we are going to, from a top-down, regulate the use of AI everywhere and sort of leave it up to particular agencies to classify certain things as high risk and to put restrictions on what you can and can't do. It seems like it's an approach that's focused on the technology itself. The US approach thus far has been a little bit more focused on the applications, right? If you're using AI and making employment decisions, you are subject to the existing laws of the country that govern employment decisions. That's sort of the perspective that it's taking so far. That also has its problems. It's been somewhat inadequate, especially because old rules don't necessarily apply that well to new tools. And so a lot of the time that I spend is actually on discrimination law and how it doesn't really sort of fit the way that we use machines to make decisions. But it doesn't mean we can't sort of update those laws and do sort of sector-specific legislation on how you should or should not be able to use AI. I think it's useful to make the distinction between people using AI to do stuff that they were already doing and people using AI to do altogether new things. Because you might think that the former, doing things that people were already doing, is easier to stretch existing legislation over and to not have to move too aggressively or to do sort of sweeping prohibitions on the use of AI because it's fundamentally things that you were already doing. I think it is slightly different when it comes to novel applications of AI. Things like using AI to generate content in various cases, right? Writing job descriptions, writing books about mushrooms, whatever it might be. You might have a little bit more of an inclination to come down a little bit more strongly there. There's a lot of talk on regulating social media companies and information platforms. I'm somewhat ambivalent about that. I've yet to see a proposal that I actually think would either be helpful or be not destroy a lot of their business models, which maybe is what you want to do, but it's not really up to me. But it is hard to walk the line between making these things healthier, but also making them still profitable enough and engaging enough that people actually want to use them. Now, to some extent, this is the what companies are already trying to do, and if they knew the answers for at least some of these questions, they'd be implementing them. I'm actually not sure the problem is an incentive problem that the companies have, or whether it's a scientific lack of understanding of how to make social media healthier. I think that I wish I knew the answer to that question. But that, I think, should be the sort of foremost thing that would inform explicit regulation of information platforms. So yeah, those are some sort of high-level thoughts on regulating AI. I do think the sort of related questions of privacy regulations are important, and the EU, again, has done a lot more than the US has. One of the challenges, again, with privacy regulation is compliance cost becomes quite a burden, and it's hard to institute privacy protections in a way that doesn't just heavily advantage incumbents, basically larger companies who have the resources to comply, as compared to the smaller ones who don't. I think in practice, what's ended up happening is that smaller companies just don't comply because they don't have the resources to do it. And you just hope that you're small enough that you fly under the radar and nobody really cares. And that doesn't seem like a good equilibrium to me. Different states have already instituted their own privacy protections. You may have seen, if you log into Zoom, it asks you if you're from California sometimes, so it gives you options to delete your data. So I think there have been, one of the nice things about this country is that you get states that can experiment a little bit, and you can see what the outcomes of those experiments look like. So hopefully in the next few years, we have a little bit more information on what appears to work and what does not. But I would like to see stronger privacy protections in the US.
Mm-hmm. Well, thank you. You brought up a number of certainly very interesting and important points. And, I think a lot of this is yet to be seen, but very good things to consider. So thank you. So I think the last prepared question before we move into some of the questions that we've received in advance of today from audience members, would love your thoughts on just the future. What are your predictions for AI, and how will it have an impact on both work and society at large?
I don't know. If I really knew, I'd be making millions off of it. No, let me think. I think that the cost of intelligence in some ways going down, and that can be kind of nice. I do think that there are still a lot of bottlenecks to making AI more generally useful in our lives. One of them, which we touched on, is the cost of mistakes. Like, it would be really nice if I could have a system just respond to my emails for me. Right? I think we're getting close to a point where I could actually save a lot of time by having my emails, like the ones that I don't really need to respond, where I need to provide information to someone or whatever, those get handled automatically. That would be really nice. I don't trust any of the systems that exist out there enough to do it. Right? I think the cost of mistakes is too high. And the other bottleneck which shows up here is I think that there's a difficulty in conveying information about my real life into a system, right? If I try to build, let's say, this email assistant, it might know everything that's in my emails, but that's not my entire life. And so, there's a lot of context that comes from the real world that I get just from walking around, and I have whatever my interaction with the real world gives me more information about my own life, which is just very hard to put into a system without getting to a point where what I would feel like my privacy was being violated, right? There's a trade-off between, I have, access to everything in my life. In order to make good decisions, a system would also need access to everything in my life, but I'm not sure I'm willing to give it that, right? So there's some sort of tensions that I see that actually make it hard for adoption. And you see this tension play out in a number of places as well, where it's hard to encode all the information from a firm or whatever into data in a way that is understandable by a machine. Right? There's conversations between people. There's the decisions that people make. There's the values that people have. It's hard to encode all of those. Now, that's not to say I don't think it can be done, but I think of that as, you might look at the rapid progress of AI and be optimistic that a lot of what we do, maybe the majority of what we do, can be automated in some way and offloaded to machines. And I think that even if the technology itself gets to a point where it might be plausible that you could do that, all the infrastructure around it, like our norms about privacy, our trust in these systems, our own need to have jobs, sort of economic concerns, I think are going to slow the adoption a fair amount. But I do think in the long run, a lot of the boring stuff that we do in our life, we're not going to have to do anymore. And I think that's going to be nice, right? I would like to be a little freer to make sort of high level thinking more of the time, as opposed to editing the next paper that I'm going to write. Those are the types of things where I think we're going to spend, or responding to emails, I think we're going to spend a lot of less time on the more mundane tasks. And ultimately, I think we're going to get to a point where it's not clear that that full employment is really something that we can necessarily achieve, or that is useful to achieve. But that to me is sort of futurist speculation that I'm sympathetic to the idea that I don't really know how everyone is going to have a job 100 years from now, or if everyone's going to need a job 100 years from now. I also know that I'm not going to be around to see it, so maybe I'm not super worried about it. But that to me really feels like I have very little insight as to what that's going to look like. It just feels so hard to predict that far out.
Well, thank you very much just for your thoughts and perspective. That's really interesting. So we received a number of questions that were submitted in advance from audience members. So we are going to field a number of those and then try to also get to as many of the questions that came through while we were live today with the 10 minutes or so that we have left. So the first question comes to us is thinking about your thoughts on kind of the future of AI from the standpoint of the fact, do you think it will be a fad like crypto, or is this going to be the next big thing like the internet or electricity?
Somewhere in between. I don't think it's well, it depends on who you talk to. Some people will tell you crypto is a fad. I think one of the big problems with crypto is it was trying to solve problems that were new problems, perhaps, or problems that people didn't really have with the existing systems. Whereas a lot of the recent developments in AI seem to be solving problems that people actually want solved, right? I mean, yes, it would be nice if I could, send money to people electronically, but I can already kind of do that, right? I didn't need crypto to make that feasible for me. It was just sort of a different way of doing it, but not necessarily easier or cheaper. Mm-hmm. I think AI actually does solve problems that people are already trying to solve, and does it probably cheaper, right? So I think there's clear demand. Now, is it going to be like the internet or electricity? Maybe. I don't think in the next 5 years. Like, I think in the same way that electricity actually took a very long time to roll out across the country, I think AI is going to take a lot of time, not because the technology is necessarily going to get that much better, but because the infrastructure you need to put in place to make it useful is still going to take some time. I do think this is my own sort of curmudgeonly view of AI is there's I think a misperception that AI growth is the rate at which AI gets better is going to continue to increase, and it's just going to sort of take off like that. And I just think that's wrong. I think it's going to sort of top out at some level kind of soon. And what that looks like is fundamentally, you're training a lot of especially the generative systems get trained on text from the internet. Once you get to like the level of competence of your average person on the internet, I don't think there's a ton more room for growth from there. Right? So yeah, anyway, that's my own sort of somewhat pessimistic view about the future of the quality of these systems. But as for their societal impact, I do think that's actually going to be quite broad, but I think the rollout is going to be slow.
Thank you very much. So the next question speaks more to where will kind of the value of AI go in terms of filtering different corporations. So, right now, most of the companies that are employing AI are infrastructure companies. Do you think that will continue, or that more model providers or top-level AI application companies will be kind of the great companies to work for in the next 2 years? Kind of where will that dispersion happen?
I think there's going to be a lot of success with people who actually have good data, I think if you look at why, actually, let me say something slightly different. OpenAI has been successful because they've just been willing to go sort of be more experimental and maybe a little bit more fast and loose than other people. And they've had a lot of success doing that. But the way that they're going to continue to be successful is if they maintain a data advantage in some way. Because at the end of the day, what they're doing technologically, a lot of people can do. Right? But what is going to make them continue to be successful is now they have this platform that a lot of people are using, and a lot of people are putting questions into ChatGPT. Now you could get the data on what people like and what they don't like, and you can use that to improve the service, right? That, I think, is where a lot of their future value is going to come from. If you think of like, someone is going to make a lot of money selling AI tools to lawyers, right? Who is that going to be? Yeah, it might be a small company that just has really great technology, but they're not going to get very far without access to really good, high quality data about, what lawyers actually want. If they're trying to edit contracts, you need a lot of examples of past contracts and how people have edited them, right? So I think access to good, high quality data is going to be a pretty good signal. And you actually already see a lot of the startups, for instance, that are trying to do legal assistance or AI driven legal assistance have tried to strike partnerships with big law firms because that's where the data is. Right. So that's, I think, where a lot of the success is going to come. And then, of course, a lot of the just sort of infrastructure companies are going to do well. Like NVIDIA is going to continue to sell millions and millions of dollars of chips because people fundamentally need the computing resources. Right. So those sort of infrastructure companies, I think there's going to be a few big players who continue to do very well there. I'm actually somewhat optimistic, though, that some of the gains can go to smaller firms that operate in a particular industry and have high quality data in that industry. Like, I don't know, you can decide who you'd rather see come out ahead in this, but like, if it's going to be a big law firm or OpenAI, I don't think OpenAI wants to be the one actually building the AI legal chatbot. Right? I think they'd rather just, provide a platform on which other people can build stuff and be responsible for the data and also for the consequences of actually deploying the stuff in the world. Because I think a lot of the challenge is going to come not from training a model itself, but from actually integrating it into a product that can be useful to, let's say, lawyers. I don't think OpenAI really wants that responsibility or wants to be in that position. It's much easier to just sort of be the platform that everybody else uses and have people with actual expertise, domain expertise, be the ones managing that sort of deployment.
Well, thank you very much. So building upon that a little bit, could you speak to and provide advice on kind of the best practices to train machine learning models from the perspective of a business expertise or driving revenue and kind of operations?
Yeah. So again, there's different types of models that we should distinguish between. When we're talking about predictive models, the problem that they're solving is really, given historical data, make predictions for really anything. But like, is this customer going to churn in the next month? Right? That's a sort of predictable outcome that you might try to get at. So best practices on that front are really make sure that the target that you're predicting is actually the thing that you care about, right? Like if you were trying to predict customer churn, great. Make sure that's what you actually want to do. Maybe you want to, prioritize sales leads. Which ones are most likely to pan out? You can try to predict those. One of the nice things about machine learning is it's quite easy to prototype and just sort of understand, is there even predictive signal in this data? Like, is customer churn even predictable? I don't know. Let's go get some data. We can throw a pretty simple model at it and probably find out in a few days, right? That's the kind of sort of rapid prototyping that machine learning enables. But this is all subject to having high quality data to work with. On the generative side, I think one of the, again, somewhat surprising insights from the last 5 years is that it is better to start with a model that is pre-trained, but doesn't actually do the thing that you want, and sort of tweak it slightly to do the thing that you want, than to start from scratch. So for instance, if you're trying to build your legal advice AI, it's better to start with a general purpose generative model and show it a little bit of legal stuff and sort of push it in the legal direction, as opposed to trying to train a legal chatbot from scratch, right? It's not clear. I mean, it's quite a robust finding over the last 5 years, but it wasn't obvious a priori that was going to be the case, right? That somehow having general but not very specific knowledge is a useful starting point. And I guess it kind of makes sense that when you don't train someone to be a lawyer from the time they were a baby, you take someone with general knowledge and then sort of push them in the legal direction. So to the extent that it mirrors human development, which is maybe a bad analogy, it sort of makes sense. But what's ended up happening is actually it doesn't take that much data to take a general purpose model and push it in the direction that is useful to you, right? Again, this is all subject to the fact that it's still going to be make mistakes and it's going to be imperfect and so on. But I think people are surprised by how little you really have to bring to the table. As long as if you have high quality data, it doesn't have to be a lot of it in order to build useful products.
Perfect. Well, thank you very much, Manish. I think that's unfortunately all the time we have. I know we've a number of questions in the chat and certainly more that people submitted, but I think that's probably the time we have for today. So thank you very much just for sharing your thoughts and expertise with everyone here. Greg, I'll turn it over to you because I have a few final words before we wrap up.
Great. Thank you, Jackie. Thank you, Manish. For our viewers, thank you for joining us and learning with us today. When you close out of the webinar, a survey will appear on your screen. So please fill that out and let us know your feedback on the session, as well as on our ongoing lineup of events. Our next event will be on October 3rd in Opportunity and Empowerment Through Art. We look forward to seeing you then. Jackie, Manish, thank you again for your time today. Take care, everybody.
Thanks so much for having me.
Thank you.